Welcome to the A320 Ventilation System lesson. In this lesson, you will gain a basic understanding of how avionics ventilation, as well as cargo compartment ventilation and heating, operates. You will also learn how to control and monitor the ventilation system using its associated overhead panels and the SD. The ventilation system provides ventilation for the following: the lavatories, galleys, aircraft batteries, and avionics. The avionics ventilation system provides cooling to the electronic components of the flight deck and the avionics compartment. We will refer to these components as avionics equipment throughout this lesson. The avionics ventilation system is automatically maintained by a computer called the AEVC, or Avionics Equipment Ventilation Computer. The overhead ventilation panel allows crews to exercise additional control of the system. Status of the avionics ventilation system may be monitored on the cabin pressurization page. The lavatories and galleys are ventilated using cabin air. An extraction fan pulls the cabin air into an extraction duct and vents it overboard through the outflow valve. The extraction fan runs continuously whenever electrical power is applied to the aircraft. Ventilation for the aircraft batteries is achieved through the use of a venturi. The venturi, contained within the aircraft skin, draws ambient air around the batteries, which is then vented overboard. The resulting airflow ventilates the batteries. The entire avionics ventilation system is operated by the Avionics Equipment Ventilation Computer, or AEVC. The AEVC provides commands to a series of fans and valves for maintaining avionics ventilation. With the associated push buttons in auto, lights out, the electric blower and extract fans circulate air throughout the system and operate continuously as long as electrical power is established to the aircraft. Two valves, located on the forward sides of the fuselage, control the amount of fresh outside air allowed into or out of the system. The inlet valve is located on the left forward fuselage. During certain conditions, this valve opens, allowing the blower fan to draw outside air into the system. The extract valve is located on the right forward fuselage. During certain conditions, this valve opens and ventilation air is expelled from the aircraft. The position of these valves can be monitored on the cabin pressurization page. Notice in this case, both valves are open. The skin heat exchanger is the primary component of the avionics ventilation system. It is used to cool the circulated ventilation air in certain modes of system operation. It uses the space between two of the ribs in the fuselage through which the air is circulated. The air is cooled by the cold temperature of the aircraft's skin. Therefore, the skin heat exchanger replaces the air conditioning system as the means to cool the avionics. Airflow through the skin heat exchanger is controlled by an isolation valve. When the isolation valve is closed, the skin heat exchanger is bypassed. When the valve is open, air is allowed to flow through the skin heat exchanger. When the system is using the skin heat exchanger, another valve is opened by the AEVC. A bypass valve opens to allow ventilation air to be expelled through the forward cargo compartment under floor. This provides passive heating to the compartment. This air is eventually expelled through the pressurization system's outflow valve. The system is controlled by the blower and extract push buttons on the overhead ventilation panel. During pre-flight, these push buttons should be in the on, lights out configuration. When both push buttons are on, the system runs automatically. The blower and extract push buttons can be used to reconfigure the avionics ventilation system in the event of a system non-normal. Let's take a look at the different ventilation configurations and see how the avionics ventilation system works during normal operations. If the aircraft is on the ground during warm ambient conditions, the AEVC automatically places the system into the open configuration. The open configuration uses outside air to ventilate the avionics equipment. In the open configuration, air is taken in from outside the aircraft through the inlet valve. Air is then blown through the avionics equipment by the blower fan. It is then extracted by the extract fan. Finally, it is discharged overboard through the open extract valve. In the open configuration, the skin heat exchanger isolation valve is closed and the heat exchanger is bypassed. Also, the bypass valve for the forward cargo compartment underfloor remains closed. Review the open configuration as presented here on the cabin pressurization page. During cold ambient conditions, the AEVC automatically places the system into the closed configuration. This configuration is used during flight or if cold ambient temperatures exist while on the ground. The inlet and extract valves are closed, and only air from the skin heat exchanger is used for avionics ventilation. The blower fan blows cool air from the skin heat exchanger over the avionics equipment. This air is then pulled by the extract fan and routed back through the heat exchanger and under the forward cargo compartment. Review the cabin pressurization page for the closed configuration. During hot conditions, the AEVC may utilize the intermediate configuration after the application of takeoff thrust while on the ground or while airborne. The intermediate configuration is essentially the closed configuration, except a small internal flap on the extract valve opens to exhaust some of the avionics ventilation air overboard. As skin temperature drops, the system changes to the closed configuration and will maintain that configuration for the remainder of a normal flight. Review the cabin pressurization page for the intermediate configuration. If the AEVC senses smoke in the avionics compartment, an avionics smoke caution is generated. By adhering to the procedure presented on the EWD, the crew places the avionics ventilation system into the avionics smoke configuration. Placing the blower and extract push buttons to override accomplishes the following. The inlet valve remains closed or closes if open. The blower fan stops. The isolation valve to the skin heat exchanger closes. The bypass valve to the cargo underfloor closes. The air conditioning inlet valve opens. The extract fan continues to run. The extract valve remains closed or closes if open, and the small internal flap within the extract valve opens. In this configuration, the air conditioning system simultaneously supplies cooling air for the avionics and fresh air for smoke removal. This air is then exhausted overboard. Unlike the previous three configurations presented, the avionics smoke configuration doesn't occur automatically. The crew must manually set the avionics smoke configuration.
That is correct. That is incorrect. That is correct. That is correct. That is incorrect. That is incorrect. That is incorrect. That is incorrect.